All right, so what do y'all remember about needing to combine fractions? You need something in order to combine. You need the same denominator. You need the same denominator. You need a common denominator. Okay, now, do we want it to be the greatest common denominator or the smallest common denominator? Ideally, it would be the least common denominator or the least common multiple. That's really called an LCM or an LCD, least common multiple, least common denominator, because if the numbers are bigger, it's just more to simplify on the back end. So, what is the least common multiple of 3, 4, and 6? That is, what is the smallest number that 3, 4, and 6 all go into evenly? 12. Excellent. So what do? We do that thing. Each of these guys is going to have to be multiplied by something equivalent to 1 that turns their denominators into 12s, right? The LCM here is equal to 12. So when we multiply an expression by something, we can only multiply by 1, because what's anything times 1? Itself, okay? So here's the question. Here's how we know what to do. This is doing that thing. This is the most important step. This is doing that thing. Doing that thing, the DTT step. What do I need to multiply 3 by to get a 12? 4. So I need to multiply by 4 over 4, right? What's 12 divided by 4? 3. So I need to multiply that one by 3 over 3 to turn it into a 12. And how do I turn a 6 into a 12? Multiply by what? 2. So I need to multiply that by 2 over 2. Now what that does is it gives me an opportunity to make this line here. So I'm going to teach you the way to do this my way. Okay. Once you have the numbers all there that you need to multiply by, turn it into one supervinculum. Supervinculum. I don't know if I mentioned it yesterday, but the vinculum is the name of that horizontal division bar. You get one supervinculum, and in the denominator goes the common denominator. Okay. So you can't just add the numerators in the beginning, and you can't just add the denominators in the beginning. A lot of people did that and got 0 in the top. You need a common denominator. When you get the common denominator, the LCD goes in the bottom, and now you just have to expand the top. 2 times 4 is 8, plus 3 times 3 is 9, minus, you got to be careful with the minus, 5 times 2 is 10. And then, of course, I ran out of room, so I'm going to start a new column. That turns into 7 over 12. I think 3 or 4 of y'all got 7 out of 12. So that's good. Bryson, did you figure out where your mistake was? Okay, good. That's the important thing. 7 over 12. That's the answer, 7 over 12. So in order to add fractions, you need a what? Common denominator. And ideally, you find the least one, because there's lots of common denominators. 24 would have been a common denominator. 48 would have been a common denominator. If you ever can't find the least common denominator, you can always take the product of all the denominators. 3 times 4 is 12. 12 times 6 is 48. 48 is a common denominator, but it's not the smallest. Okay, we want to keep numbers small and manageable. All right, so how does that lead into today? Well, today you're going to be learning how to add and subtract rational expressions. That's ratios of two polynomials. All right, I'm going to go through these little steps instead of working it first. I'm going to go through the steps first. Step 0 that I'm going to add is the same thing that we did yesterday. We're going to factor the denominator especially. Okay, why do we factor the denominator? Because it helps you find the what? LCD. So just like we did with the numbers, we're going to find the LCD. And it even says you might need to factor the denominator. Then we're going to do this step right here, step number 2. I'm going to put a couple of asterisks by us. This is the DTT step. Okay, as Aslan said, the do that thing step. It's the magical step where you multiply each expression by what is missing from the LCD. Then it's just a little bit of math. Then you're going to expand the top, combine like terms, distributing the negative if it's subtracting. Ooh, I'll show you one of those. Distributing the negative, it's the subtracting. And then in the top, number 4, it doesn't always work, but you're going to see. See if you can simplify the top by factoring and reducing even more. It doesn't always work, but at least we check. And then number 5, like we did yesterday, you're going to identify any values that make the expression undefined. That's going to be setting the denominator equal to 0, okay? And then I'm going to add a 6th step here at the end when you're all said and done. If you're not doing it already the whole time through, which like I do, right? You're going to smile at the end because you've accomplished something, all right? Now, I smile all the way through the problem, and some of y'all do too. I watch y'all, and you smile when you do math, right? But if not, smile at the end. You ready? All right, let's try it. Example 1, add or subtract, identify any excluded values, and simplify your answer if necessary. Okay, I got a rational expression, it's a linear over a quadratic, minus a rational expression, a linear over a quadratic. What, again, do I need in order to combine two or more fractions? I need a what? A common denominator. Look at my two denominators. Aren't they already common? They are already common. So I don't need to factor the denominator if I don't want to. I know what the LCD is. It's going to be x squared minus 1, okay? Which happens to factor into x minus 1, x plus 1 if you want the factored version. Either one. It already has a common denominator. So I'm going to do a new column. I'm not going to work from left to right. Once you have a common denominator, you make supervinculum, one big division bar, and you put a single representative of the LCD in the bottom. All right, now all you got to do in the top is expand, okay? 3x plus 2 is already written. There's nothing to expand. But here's where you can get in trouble. A student in third period finished her homework, and she missed one the first time through. She went back and reworked it and answered it again and got it wrong again. And she came up and asked me what her problem was, and I found it. She did not do this right here. You need to distribute this negative, okay? This is a quantity, 6x plus 1, and that negative has to get distributed. So that would become minus 6x, which she was doing. She got the first term, but she wasn't distributing it to that second term. She kept it as plus 1 instead of minus 1. So don't let the subtraction kind of mess you up. All right, now that I've got it fully expanded in the top, I just collect like terms. So 3x minus 6x, that's negative 3x. And then negative 2 minus 1 is negative 3. All right, this could be a final answer. This could be a final answer, but we could also keep going. This is the expanded answer. We could also factor. The factoring is really the more desirable of the two because when things are factored, they're easier to use and they're easier to see if things divide out. So if I factor the bottom, it's x minus 1, x plus 1. And then what can I do in the top? Can I factor the top at all? What's the first rule of factoring? Look for a greatest common factor. And there is a common factor of 3. In fact, I'm going to pull out a negative 3, and that'll change both signs. That makes it x plus 1. Now, what do you freaking notice about the x plus 1 factors in the top and bottom? They divide out. Now, because we're going to be asked for this every time, what are the excluded values? You want to find the excluded values before you divide anything out, just like we did yesterday, okay? So, here it is. If x minus 1 is the factor, what's the taboo root that's associated with it? Plus 1, yeah. And if x plus 1 is the factor, what's the taboo root? Minus 1 or negative 1, yeah. I was observing Coach Richter's class yesterday, and they were watching a video of her doing it. She makes her kids go off to the side and set each factor equal to 0, and then solves like that, which is fine if you still need to do that. I'm trying to get you to think a little bit beyond that and to be able to look and say, oh, x minus 1 is the factor, so 1 is the root. Now I'm putting not equals because they make the denominator 0. So we're essentially finding the domain. So x cannot equal plus or minus 1. That's what we'll write. Okay, that's essentially the domain. Now, since I've already found the excluded values, now I can go, those divide out, and I'm left with negative 3 over x minus 1. And that would be the answer. Negative 3 over x minus 1. By the way, that negative, which is in the top, sometimes when we write it, we also write it off to the side on the exact same level as the division bar, the vinculum. I would not recommend doing that because one thing, it could drift too close to the vinculum, and now it doesn't look like it's a negative at all. And if it drifts to the bottom and you don't distribute, now it's wrong. So it's safer just to keep it in the top with the negative 3. Okay? All right. Now, in pre-cal, here's what we would add to it so you can start preparing for your future. Because I divided out the x plus 1, I usually make a note to someone who might want to use this expression. Hey, don't use negative 1. It's not in the domain. I don't need to worry about using 1 because x minus 1 is still in there, so it still prevents it itself from being used. But negative 1 might seem like it's allowed. So Some people on the test actually wrote their answers like that, which means they're paying attention in class. So I didn't count off if you didn't have that, but it's a good habit to get into. Okay. All right. This is also then your simplified answer, which is what we really want to get at. Okay, the simplified answer. Now, you're not always going to be able to factor it, and if you do factor it, you're not always going to be able to divide something out. This is kind of a rare case where it does happen. You'll see the next two will try to factor it, but we're not going to be as fortunate. Okay. Any questions on letter A, capital letter A? All right. Did y'all smile? Did you remember to smile? Step 6? Yeah. Yeah. No, some people start smiling. Think of a baby penguin farting. Or maybe that doesn't make you smile. That didn't make you smile. Listen, that made you kind of go gross, right? Maybe a baby. Just think of a baby penguin. Maybe that's all you need. Why does it need to be farting? You'd be able to tell if it farts because those little wet feathers at the back would just shoot up real quick. Penguin fart. Okay. Do whatever you need to smile at the end. Letter B. I've got a linear over a quadratic plus a linear over a linear. Two rational expressions. Do they currently have a common denominator? No, they don't. They don't. So guess what we need to do? We need a factor. We need a factor. All right, so let's factor. I'll switch to blue here. X minus 3 is already factored. It's factored when we know it's a linear factor of the form mx plus b and there's no common factor. Now the bottom looks like it double bubbles, doesn't it? Leading coefficient is 1, so it'll be an x and an x. Factors of -4 that add up to +3. 4 and 1. Which one's positive? Which one's negative? 4 is positive, 1's negative. Very good. Plus 5x all over. It's already linear, but is there a common factor? 2. So I'll factor out the 2 and I get x plus 4. All right, now we're primed to find the LCD. Here's how you can find the LCD when it's already different and you have polynomials. You need at least one of each factor type. That's the easiest way to get it when you have variables. You need at least one of each factor type. So as I start in the bottom left, I notice I have an x plus 4 in the first one. I also have an x plus 4 in the second one. So the x plus 4 is already common in both terms. Yes, yes? But there's at least one of them there, so I need at least one x plus 4. Now, could I or should I say that I'm taking x plus 4 squared since there's two of them? Would that work? That would work, but we're trying to go for not just the common denominator, we're looking for the what? The least common denominator. So we don't want to square it. We don't want to square it. They each have at least one x plus 4, so we'll leave it as x plus 4. And then I mosey to the second factor, which is x minus 1. I need at least one x minus 1. And then I go to the third one, which has a 2 in it. Whoa, wrong tool. I have a 2 over here, and so I need at least a factor of 2. So there is your LCM. It's x plus 4 times x minus 1 times 2, which typically when we have constants, we write them in the front. So 2 times x plus 4 times x minus 1. And again, the x plus 4 and the x minus 1 can be written in either order. Commutative property. There's your LCM. All right, now we're ready for the do that thing step. You ready? The DTT step. I'm going to go ahead and write x minus 3 over x plus 4 times x minus 1. And I'm going to put a parentheses here with a vinculum. I'm going to do the same thing with the next one, just like we did in the warm-up. I have a 2 times an x plus 4, and then times something with a vinculum. I need to make both of the denominators the LCM. So I'm going to go through and see what's missing and multiply by what's missing over itself. So in the first factor group, I have an x plus 4 and an x minus 1. Which one am I missing? I'm missing the 2. So I'm going to multiply by 2 in the bottom, and I'm going to make it legal by multiplying by 2 in the top. 2 over 2 is just another name for 1, right? Which is fine. All right, in the next factor group, I have 2 times x plus 4. What am I missing? X minus 1. So I put 1 in the bottom, and I make it legal by putting the other one in the top. Now they have the same denominator, don't they? So now I go to a new column, and I put the supervinculum. And in the bottom, I'm writing 2 times x plus 4 times x minus 1. Okay, that's my new common denominator. One term now. And now all I got to do in the top is distribute. So let's do this carefully. I would put the x minus 3 in parentheses, and I'm multiplying by 2, which means I have to distribute this 2 to both terms from the right-hand side. So that gives me 2 times x, which is 2x, minus 3 times 2, which is 6. Everyone okay with that? Distributing from the right-hand side. Now, luckily, I have a plus sign here, so I don't have to worry about possibly distributing a negative and missing it. I'm just distributing a positive 5x into both of those terms. So I get a positive 5x squared and a minus 5x. So I expanded out the tops, and it's all over the denominator. Now all we got to do is collect like terms. Okay, so I start with the 5x squared. That looks good. I have a 2x minus 5x. That's minus 3x plus 6. All over 2 times x plus 4 times x minus 1. Now this is a decent place to stop. You could stop right there if you want. Or you could expand the bottom back out. If you're going to expand the bottom out, I would FOIL the x plus 4 and the x minus 1 and then distribute the 2. I will tell you that we like it factored. If there's an option of leaving it expanded versus factored, we like to have it factored. Now, there's one last thing to consider here. I have a quadratic trinomial in my numerator. Does this guy right here, off to the side of my workbench, does 5x squared minus 3x plus 6, does it factor into a double bubble? And if so, is one of those factors x plus 4 or x minus 1? That's really what I'm after. Because if one of the factors is one of those, then I could do what I did right here and divide it out. And we want to do that to make it reduced or simplified. So let's look at the x plus 4 factor first. Is it even possible that x plus 4 is going to be a factor of the top? Does it even have a shot at being a factor of the top? The answer is no. A lot of you are shaking your head no. Do you know why? Without even trying, we know it's not going to work. Remember the rational root theorem that said any remaining root is going to be a factor of the constant 6 over the leading coefficient 5? Is 4 a factor of 6? It's not. So x plus 4 does not have a shot at being a factor. What about x minus 1? Does that have a chance? It does, because 1 is a factor of 6. So maybe this factors as x minus 1 times something. Let's see. Let's see if we can factor it. Now, truth be told, when the leading coefficient is not 1, you're probably not going to have to factor these on your homework or on a test or a quiz in Honors Algebra 2. But if you're interested in being a bigger, better person, moving up to pre-cal and calculus, this is totally fair game. We factor stuff like this all the time where the leading coefficient isn't 1. Let's see if we can do it. 5 is prime. That's nice. So if it's going to work, it's going to be a 5x and a 1x. 6 is not prime. So it's either going to be a 6-1 combo or a 1-6 combo. Let's see if it's going to be one of those. Let's try the 6-1 combo. You get a 6 on the outside and a 5 on the inside and a 5 on the outside. 6 minus 5 is 1 and 6 plus 5 is 11. We're trying to hit a 3, so it's not going to be a 6-1 combo. What about the 1-6 combo? It's a 1 on the inside and a 30 on the outside. Ay caramba. 30 minus 1 is 29. 30 plus 1 is 31. So that's not going to be that. So since 1 didn't work, guess what? X minus 1 is not going to be a factor, and we're not going to get to divide anything out. Yeah.
Why is it a plus 6 not a negative 6?
Oh, it should be a negative 6. Yeah, I don't know why. I just miscopied. Good eye. Good eye. Yeah, look at that. It's a negative right here, and I just changed it to positive. I'm just a positive guy, you know?
I love the people that actually point it out.
Yeah, absolutely.
I'm sure other people were thinking it.
We got some shy ones in here. Yeah. That was Stella for the record. I'm recording this, so that was Stella. Stella H. I won't say your last name, Hales. Okay. She's the one that pointed it out. Yeah, everyone was thinking it, though. It should be minus 6. Now, that's not going to affect the way it factors. Let's quickly see if the 3-2 combo works. 3 and 2 or 2 and the 3. If I do the 3-2 combo, it's a 3 on the inside and a 10 on the outside. 10 minus 3 is 7, not plus or minus 6. So it can't be the 3-2 combo. Here's our last hope. Is it the 2-3 combo? We get a 2 on the inside and a 15 on the outside. What's 15 minus 2? Is it plus or minus 6? Nope. So guess what? It doesn't factor. So that's as good as it gets right there, with the correct constant in there of -6. Now, learn from my mistake, right? When you expand it out and you go to the next line, it's all about careful inventory. Typically in the past, remember, I underlined the thing. So I'd underline that. I would double underline this. And usually at the end is where people make their mistakes, including me, right? I forsook the last value and I just saw the 6 and I didn't write down the negative. So always at the end is when your mind is relinquishing the thought and you're trying to move on to the next bigger, better thing, and you make careless mistakes. Okay, so this is as good as it gets unless you want to expand the bottom. Now, since nothing divided out, we can go to our excluded values just by looking at those two factors. What are they? X cannot equal what? -4 and +1. There you go. The opposite of what the factors show. -4 and +1. Okay. Any other comments or questions on this one? This is the third time I've done this problem today, and in the other two classes, I didn't make the mistake with calling it +6. So I knew what the answer should have been, and I still made a mistake. All right, there's only one more to go, and this is usually where I say you try it on your own, but there's one little lesson that we have to learn from this problem. So I'm going to have to work it with you, okay? We got something minus something. We're going to need a common denominator, aren't we? So step one is to what? Factor it. Let's factor it. I'm going to use purple here. Purple on a Friday afternoon. In the top, I could factor out a 2. I don't necessarily need to factor the top, but I might as well try to factor the top in case something divides out with the bottom right away. That gives me x squared minus 15. And the bottom, I get x minus 3, x plus 3. It's the difference of squares. And then I get minus. Ooh, so I'm already alerting myself to the fact that there's a minus there. I got to be careful, right? Cuidado, cuidado. And then I just get an x plus 5 over. Now, that's a 3 minus x. I already have an x minus 3 in the first one. Is x minus 3 the same as 3 minus x? No, subtraction is not commutative, right? 7 minus 5 is not 5 minus 7. So do I have to treat 3 minus x as its own separate unique factor? You would think so, right? That would be the common sense thing. Yeah, it looks different, so I need at least one of each factor. I'm going to have to include it. But this is where this problem has a little seed of education in it. Let's come off to the side. If I write 3 minus x, I want to show you what we could do with it. We're just going to manipulate it. Let's go ahead and just commute the terms. Let's write it as negative x plus 3. That's legal, right? That's the commutative property of addition. Now, since I have a negative in front, let's factor out the negative. That essentially changes both of the signs, doesn't it? So that's negative x minus 3. Oh, now notice there is really a hidden x minus 3 factor inside of it, right? So here's what I'm going to do. I'm going to rewrite the denominator over here as negative x minus 3. Now, what do I do with the negative out front and the negative in the bottom? Well, guess what I can do with them? I can multiply them. I can multiply them. So what is my supervinculum going to be here? That turns into a positive right there. So what's my LCD? What's my LCD? I need at least 1x minus 3, and I need at least 1x plus 3. So there's my LCD. It's x minus 3, x plus 3, or x squared minus 9 if you still like it in that version. I'm going to leave it as x minus 3 times x plus 3. Oops, I'm doing the wrong thing. I'm not ready for supervinculum yet. I need to do something right here. I need to multiply this one by something to get it to match. I don't need to do anything in the first one, do I? It already has x minus 3, x plus 3. It has both of the factors that I need. But in the second one, I only have an x minus 3, so I need to multiply by what? X plus 3 over x plus 3. Yeah, there we go. Now I can go to supervinculum, and my denominator is x minus 3 times x plus 3. Okay, now here's what I'm going to do. Right here where I multiply those together, what's the negative times the negative? A positive. So I can turn both of those into positive, and now it becomes a plus sign. Okay, it's like pulling that negative out front and doing minus a negative. It's the same as adding. So that's kind of cool. That killed two birds with one stone. If you're into killing birds and you got to kill 2 of them, but you only have 1 stone, but you're like, these 2 birds must die. But alas, I have only 1 stone. We just killed both birds with a single stone. We got rid of the negative out front, so we didn't have to distribute it. And we put the other factor in terms of one we already had. So we didn't need a separate third factor type. Right? Kill 2 birds, 1 stone. Lucky shot. All right, so now what do? Now we just expand it all out. So even though I factored the top, x squared minus 15 was not a difference to 2 perfect squares. But I'm going to distribute the 2 back in now. So I get 2x squared minus 30. And here's the plus side now. So what do I do with the x plus 5 and the x plus 3? I just got to FOIL them out. Okay. Now see if you can do the middle term in your head. See if you can stretch yourself here. The first is going to be x times x, which is positive x squared. The inner is 5x. The outer is 3x. Right? Y'all see that? 5x on the inside, 3x on the outside. What's 5x plus 3x? 8x. Okay. If you can force yourself to start expanding these binomials in your head, you'll be taking your head to a level that it's never been before, and it won't ever go back to the same size. You'll be better for it. Okay. The more you use your mind, the stronger it gets. And then 5 times 3 is 15. That's the last. So first, outer inner we did together, and then last. All right, now we just need to carefully, and I say carefully this time because it's a warning to myself. Stella caught it on the previous one. I need to write everything in descending order, carefully and slowly. 2x squared plus 1x squared. I need a new column over here. So my numerator is going to be 3x squared. And then I have plus 8x. And then I have a negative 30 plus 15, which is a minus 15. And it's all over x plus 3, x minus 3. X plus 3, x minus 3. Are we done? No, we do this last little step right here. See if you can factor and simplify the numerator. Just see if it happens. Okay? It's actually possible because notice our constant is 15 and 3 are the roots of the bottom, plus or minus 3. 3 is a factor of 15. So can I factor the numerator? Let's see. 3x squared plus 8x minus 15. Let's see if it factors. If it does factor, fingers crossed, maybe one of them is x plus 3 or x minus 3, and we can divide it out. All right. 3 is prime, so it's got to be a 3x and an x. Now, 15 is not prime, so it's either going to be a 15 and a 1 or a 1 and a 15. Let's do the 1 and the 15 first. We'd get a 1 on the inside and a 45 on the outside. I don't think that's going to be it. That's not going to give us an 8. What about a 15 and a 1? It gives us a 15 on the inside and a 3 on the outside. 15 minus 3 is not 8, so that's not going to work. So we're down to the last grouping here, either a 3-5 or a 5-3. Okay, and this is the one that we're hopeful about because then we have 3 factors on the bottom. Could it be the 3-5? Well, we get a 3 on the inside and a 15 on the outside. What's 15 minus 3? Is it 8? Nope, so it's not the 3-5 combo. What about the 5-3 combo? 5 on the inside, 9 on the outside. What's 9 minus 5? Not 8. Criminy. Does it factor? No. So either that's your final answer, or in this case, if you want to expand the bottom out, you can factor or expand it back out as x squared minus 9. Either one of those is the final answer. Of course, on a multiple choice question, you'll have to match it up to one of the answer choices. If it's a short answer or a free response, either one of those would work. Now, the last thing we do, nothing divided out, so we can get our excluded values by looking at this one right here. What are the 2 values that are off limits here that make the denominator 0? Plus or minus 3. Yep, that's it. Do we need to worry about values that make the numerator 0? No, because 0 in the top by itself is okay. 0 divided by 5 is 0. 0 divided by 10 is 0. We just can't have a 0 in the bottom. All right, that's it. That's the whole lesson. Not that difficult. It's kind of like what we did in the beginning. It's a skill that you already knew coming in. Just do that thing and be careful. Don't rush yourself. When you rush yourself, you're going to make careless mistakes. Okay, and Stella's not always going to be there to bail you out. Right, Stella? Right. All right, any comments or questions? You got the rest of this period to work on your homework, and then you got all of Monday to work on it. So you might run out of math. So let's just say on Monday, let's just make it a BYOM party. Bring your own math, okay? If you run out of math in this class, bring something else to work on. All right, we're going to review on Tuesday, and we're going to quiz over 10.1 and 10.2 on Wednesday.